Hello everyone, this is Mix K. I'm not going to be in today, so I'm just making a short video to go over some of the notes that we were going to talk about. So in this video, I'm going to talk about enthalpy of reaction. So enthalpy, remember, is just heat energy, and we use delta H for that. Now, when we're talking about the enthalpy of a reaction or the enthalpy of something specific, and we're writing it in like a per mole unit over here, okay? That is usually we use delta H because it is a standard amount. But if we're just talking about any old amount of energy, of heat, we just use Q. So if I'm solving for a specific amount of energy, I would use Q. But if I'm talking about the fancy value that is a standard for the reaction, I would say delta H. Now, if you notice, this delta H value is negative. That negative means that energy is being released. So this is an exothermic process. Now, that kind of means our energy is acting as a product in our reaction. We are producing that energy. Now, if we reversed this reaction, if I wrote it the other way around, so instead of it being the formation of water, it's the decomposition. Okay. What that really just does is flips the sign of our delta H. Because by flipping this reaction, we have moved that delta H over to the reactant side, which means I need to add this amount of energy to get my reaction to occur, which means that I'm adding it over here. It's a positive, and it's an endothermic process. So when we have tables of these reactions, we don't need to have both of these values put in there because the reverse will always be the same as the forward, just with a negative or positive sign. If it's negative, it's exo. If it's positive, it's endo. Now, how do we use this productively? Well, you're going to notice that in that value, it is actually written out as per mole of reaction. So what does that mean? Well, that means that when this reaction occurs, this is how much energy is released for these amount of moles. So if I react 1 mole of hydrogen fully, I am producing this much energy. If I react half a mole of oxygen, I am producing this much energy. If I react a mole of, or I produce a mole of water, it is producing this much energy. So what does that mean? Well, now we kind of have a new conversion factor that we can use. That no matter what we are doing in this reaction, we have the amount of energy that will be produced. So for example, if I have 1 mole of hydrogen, it is going to produce 286 negative, because it's producing it, kilojoules of energy. If I have 0.5 moles of oxygen, it is going to produce negative 286 kilojoules of energy. So we're noticing here, now we have conversions we can do. So now we can do mole problems. Now we can do a stoic problem. New conversion factor unlocked. So now I can go back and I can go from energy to moles of reactant now, or energy to moles of product, or products to moles of energy or units of energy. So let's say I have 10 moles of hydrogen gas. And I want to know how much energy is produced, because this is exothermic, when 10 moles of hydrogen gas are reacted. Well, now I have a very simple conversion factor I can use. 1 mole of hydrogen gas produces negative 286 kilojoules of energy. This mole is acting like a coefficient of 1 mole of reaction. So now all I have to do is multiply that by 10, and I'm going to get this much energy is released. And it's that simple. Now, what if I started with energy instead? Well, I could do that. Let's say I have, what do I have on my next slide? too much of a mess. I'm going to just erase this slide again. Okay, let's say instead I start with kilojoules of energy. Well, if I have, let's say, mental math, doing some mental math. Is that, I think that's, so let's say we do a reaction and this much energy is released. And I want to know how much oxygen was used in this reaction. So I'm going to start with my kilojoules, and just like any other Stoic problem, I'm going to move my unit to the bottom, and I'm going to use my conversion factor. So I know that negative 286 kilojoules are released for every half a mole of O2. So now I just got to do out the math. So 572 divided by 286, I made those numbers easy. That's going to be equal to 2 times 0.5 means I produced, I forgot my unit for mole, 1 mole of O2. And that's it. New conversion factor. So if you can do a Stoic problem, you can do this. You just have to remember that this is the amount of energy for the way the reaction is written here. Okay, so if they give it to you written like this is how much energy is produced. 1 mole of hydrogen produces this much energy. Half a mole of oxygen produces this much energy. A mole of water is produced, it releases this much energy. Okay, have a wonderful day. I will see you all soon.